All right, guys, welcome to the Monday morning meeting of the CSI Implementation Group. Today on the agenda, it looks like Luis has a demo you want to run through. Do you want to go through that first?
Sure, that'll be great.
All right.
Um, Let me share my screen again. Share. Oh my goodness, this is difficult. Okay, so I'm gonna share my code. It'll probably be easiest. You guys see that? Okay.
Yep.
So this is inside. This is a fork of the CSI Volumes GitHub that we created the other day for Brad and Kubernetes CSI, but I haven't. This is still in my fork. But as you can see, is a single file called CO test. This is like a example file of how it will work. And then inside driver, we have a, actually, let me move driver test. We have two files actually, driver.go and safe go routine tester, which is kind of a side effect. But driver.mock.go is generated. So if we go to go here, we can see that we say generate the from the source of using the container storage spec, whatever the output of the protocol buffers, and then it outputs that out into a file called drivers mock. So you can see this is all generated mock stuff. Okay. So if we go back to here, this is a this file called driver.go is meant to make it simple to write unit tests for COs. Okay, so it does the automatic starting of a server, registration, stuff like that for you. It is only 119 lines of code. So I told you it was small, and so now that those files are there, let's look at the interesting stuff, which is how it's used. So here is a example of plugin info response. So plugin info response, it's a test of not using a RPC connection. It is making a call on its same go routine and just for simplicity. So we have here, we're going to create a mock. We're going to use the mock driver to create a new mock identity server. As you can see, this is all real stuff. This is a real struct there. This is the output. This is what the mock function is going to spit out, okay? And then we have our expectations. We expect that our get plugin function is going to be called with nil for context and some input, and it's going to return out with some nil error, and it's going to be called one time. So the mock API is quite powerful. This is just an example of what you can do with it, but you set your expectations and then you make the actual call. So here it is, like driver get plugin, and this exercises this part here, and then I get the name just like I would from any other call for protocol buffers, and it all works. It's because what I got here in R came from return in output here, okay, which is available here. So what I'm checking for, just for simplicity, is this mock name here in out. So I'm saying name should be, if it's not equal to mock, then there's some type of error. So that's just the simple stuff. So now let's look at something that's a little more complicated, which actually sets up a server, RPC connection, and everything. So here again, we set up a new controller. Again, we set up a new identity server. We set up the same thing, the in and out. And then we say, except the same thing I expect in this driver, I expect to get called get plugin info. And this part's important. It checks the arguments, but since it's a different server on a different side, you won't have the same pointer. So I just say the context is any. I could care less. Doesn't matter. So then it checks the value of in, and it returns out just as before. Okay. And now this is where it gets it uses the APIs from the little driver.go file with 119 lines that I showed you before. Because what it does is you say, I want to create a new mock driver, okay? And I want to register just the identity server, okay? And then you create a nexus, meaning that it creates both the client and the server connection for you, okay? And then just returns it, and then you say defer the close, and it closes the connection and the server for you. And then you make the call. And this happens over the network. You get a response back, R, and again with R, we check for mock value. So the cool thing about this is you can test whatever you want from the CO. You can make it fail on purpose. You can make it wait some long time. You can do whatever you want. The mock API is quite powerful. Like if I say driver.expect, and then I say get plugin info, and then I say something like I can say things like do this when this happens. Okay, I can provide a function and I can do whatever I want. Or I can say something like return or set the argument. It's quite powerful, the interface. You can make it work to whatever you would like. So now that I have that, let me just show you. Here, I say, there's my little CO test. I say go test. Bam. That's how fast it was. So, and the cool thing is too that I think that this is great for CO testing, but when as a driver developer, you don't even need the mock stuff. You just use the protocol buffers and start sending messages to yourself. You just have to set up the server and things like that, just like this did. So I may create just a tiny, even smaller file for driver developers just to set that nexus, and then have the client just send whatever things you want to yourself. And the cool thing is that my suggestion is that this is its own repo because it's so tiny, and then propose this to the CNCF. That's my suggestion. Any questions?
Pretty cool. That's really cool. I guess what this is going to be able to allow is unit testing on the CO side, foresee the various components that we're developing, picking up this code and building their unit test libraries off of it.
Mm-hmm.
Okay.
Exactly right.
So that means the external attacher can reuse this to do unit testing, and the mount component of the entry volume plugin, which also calls out to the CSI driver, can do the same.
Yes, and the cool part is that as you're writing the code, you have a set of expectations. You can force using the mock function to do whatever you want it to return.
Yep.
So
then Jan and Vlad should take a close look at this when they get a chance.
Yeah.
Yeah, I will take a look. Out of curiosity, you said this can work over network?
Yes, it does work on the network already. So
okay, cool.
I'll show you. If you go to driver and driver.go, I have here, you can see it says start. So here's a net listen. And the cool part is that I looked at HTTP tests to see how it worked, because I wanted to base it off of that. So it has a value of 0 for the port. And what it does is that a 0 for the port automatically tells the net listen to automatically give you some random port on the system. So I don't even have to track ports. And then here we have go serve. So go serve is a Go function that serves the gRPC server. Now,
okay.
I just want to give you one little side effect, and that is this. I want to make sure I talk about this. The mock interface has what's called a tester error something interface to output its calls. The unit test framework in Go, it says specifically, do not use tfatal on another Go routine. You must be in the Go routine that executed the test. Okay. The thing is that the mock interface uses tfatal all over the place. And tfatal is, as you saw with the driver interface being mocked, is running in a Go routine in the server. Okay. So what I did is that I created a new interface, new struct, a new interface, and I passed this into the mock setup, so that as such, let me just show you. Here, instead of passing T to the mock controller, I pass in this safe Go routine tester. Okay. So instead, what it does is when it calls tfatal, it's not going to call the tfatal from the tester. It's going to call this, which is going to call fprint and then panic. So, which is a nice way, because if you don't do this, it just locks up the entire testing framework. So it's like a what is it called? Deadlock. That's what it is. It deadlocks. But this solves the issue. That's the only side effect. Any other question?
Yeah, you mentioned that something about CNCF. Can you elaborate on that?
Yeah, so my goal, I think we talked about this last time, is my goal is to put this in a separate repo, not in the Kubernetes.ci one. I'll probably create one of the CSI volumes called test, something like that, and just put these functions in there, and then take this and propose it to the CNCF. I don't know if we should do it now, or maybe just leave it now, and we use it, and then we'll propose it later. But to propose it for COs to use as testing framework.
Yeah, I think what we should do is start with our own private repo, which we already have.
Yeah.
Develop in that, and then start using it for our own testing, for external attacher, for all the different components that we have. And then once we deliver something and it is actually testably usable and useful, then we can consider porting it into the container storage interface repo.
That's fine with me. So I'll take as an action item is that I'll create a new repo of a CSI volumes called test. I'll put the stuff in it.
Okay.
And then we're off.
Cool. One more thing, I might create a new repo today because I hate that CSI-volume neighbor that I know.
It really doesn't matter to me, so you guys can do.
But if I'm not feeling lazy, then I'll do that today. Otherwise, we'll leave it as is.
Okay. Yeah.
Okay. So what I wanted to discuss today was the design doc. I have sent a PR to the community repo, capturing what I think is the design with all the feedback addressed, including the latest from Jan about get node ID. So if you guys could take a look at that today and see if you have any questions. Otherwise, LGTM it, and I want to get that merged so we could use that as a point for collaboration. And the final API for both attached volume and CSI volume source are in there. Please take a look at that as well. Today, I'm going to be generating the actual PR for the API. So if you have any feedback, let's get that in as soon as possible. There shouldn't be very many surprises here because we've discussed this at length in the past already. But please take a look at that as soon as you can.
Do you have like a Go doc to Markdown converter or something, or did you have to type this all over again?
No, I did manually.
Oh my goodness.
Yeah. And there was one item that Jan brought up, which was about how get node ID should be handled, and that's going to be a little bit tricky because there's going to be, it's one of the few components where it's reaching across the various components that we have. So get node ID is a mechanism by which CSI allows the storage vendor to have its own way to reference individual nodes. It doesn't have to understand the Kubernetes node IDs. But what that means is that in Kubernetes, before we do a controller publish volume, we need to be able to do the conversion from the Kubernetes node ID to the storage provider's node ID. And the way that we're going to do that is the sidecar container that is running as part of the daemon set, which is going to be responsible for doing the Unix domain socket registration, will also probe the driver with a get node ID for that node. And once it gets the node ID, it's going to apply it as a label to the node API object. And then once it's available in the node API object, the attacher, before it does an attach, is going to look at the node object and make sure that the relevant label is there to do the mapping to that particular CSI driver's node ID. It's going to pull that label off and use it for the controller publish. So that's coordination between those two pieces that we have. Which reminded me that there's a component that we didn't assign to anyone when we started working, which is the sidecar container for the kubelet. There were basically 3 sidecar containers. One is the external provisioner, which Brad's working on, the external attacher, which Jan is working on, and finally the helper container, which is responsible for the Unix domain registration and also this component. So I'm going to go ahead and take that work on myself because it relates to the Unix domain socket registration anyway. And so we'll do that, and it'll do this setting up of the label on the node ID object. Jan, since you're the one who's going to be consuming this, does that sound okay to you?
Well, 2 things about that. As far as I remember, node ID is a map, it's not a string.
Let me double check. So node ID is a map. Why the hell did we make it a map?
Okay, it can be a map, but then it can't be labeled. It should be annotation with JSON.
Yeah.
Problems with that.
Actually, I think I have a issue to change this to a string as well. We did this with volume handle. Volume handle used to be a string plus a map. And so I fought long and hard to get that collapsed down to an ID. And I believe as part of the same issue, I was asking to collapse the node ID down to a string as well. But you're right. If we're unable to do that, then we'll have to stick it into an annotation. Otherwise,
that is that that requires the sidecar container or whatever it is to write to nodes, and that's usually something that we don't allow random containers.
Yeah. Unfortunately, I don't think there is a better option to get around that. I think the argument we're going to have to make is that the CSI volume components.
Can you repeat the issue? I didn't quite hear it.
So Jan was saying that in order for this to work properly, the helper container that we have is going to need permissions to be able to write the node status object. And that's not necessarily, or the node object. And that's not necessarily something that you grant to sidecar containers normally. It's technically only Kubernetes components should be operating on the node object. But in this case, I think the argument is going to have to be made that you are adding a basically something that is extending Kubernetes functionality. And if you don't give it access to the right objects within the Kubernetes API, it's not going to work.
Is there precedence for this? Like
Uh,
some external component, maybe a service, a Kubernetes service, maybe?
I mean, we have a bunch of Kubernetes components that do it, but I don't know if any external components that do.
I see.
So we'll see.
Basically, we don't allow anything that runs on a node to modify the node, only the status.
Yep.
Okay.
I think we can leave it there for alpha and then decide what should
Sure,
we
we
do with that.
Let's definitely write this on the minutes as something that we need to take a look into.
Yep, I'll add it.
That way we won't forget about it.
So that was the one big open item I wanted to discuss with all of you. I think for alpha, it's pretty clear what we're going to do, but you're right, for beta, we should take a look at the permissions issues around that. And that was it. I think the rest of the design includes all the feedback we've been talking about. In particular, the attach volume object is now called volume attachment. The status, instead of containing conditions, basically has a Boolean which indicates whether it's attached or not. And then there's two error fields which can be populated when there is an error on attachment or detachment. And the what each component is supposed to do is spec'd out there. So for everyone who's working on a component, take a look at it, make sure it makes sense, and poke me if it doesn't. Also, I wanted to set up a meeting tomorrow morning since I'm going to be gone on Wednesday to make sure that we're closed on all this stuff. Would you guys be okay doing a meeting 30 minutes earlier tomorrow morning?
Yes, that works.
Okay.
Yes, fine.
Okay, I can manage.
Okay, so I will then set up a meeting for 9:30 a.m. Pacific time tomorrow. And then keep an eye out today for a PR containing the API. And that's pretty much it. Any other questions, comments, concerns?
I have two questions, but I'll
Yes.
make sure that. Okay. First question is, Friday I started writing the driver side of our code for Portworx, and we had two questions, myself and another colleague, is specifically on validate volume capabilities.
Yep.
This function said that it must be written, must be supported, and it brings in volume info as a request, which is a volume handle, but it's for pre-provisioned volumes. So how is it that the CO can get a volume handle for a pre-provisioned volume? Does it do list volumes first?
It doesn't need to. So if you look at the volume info message, it contains the capacity and the volume handle. And the volume handle today is basically just is going to be the ID, and then there's going to be the metadata, which is going to get pulled up into volume info. And so if you think about it, this is similar to the way that we do pre-provisioning today for volumes, which is you provide a volume name and some additional information.
Okay, so that means that the driver should not verify that the volume handle exists. It should just verify that the capacity is capable of supporting that.
So I think the purpose of this particular call was to ensure that for this particular class of storage that there is enough capacity. Honestly, for Kubernetes, we don't need it. This was kind of something that the Mesos guys really, really wanted, because everything in their system is about everything in their system is a resource.
Okay.
And so they wanted some way to be able to say, I want not just capacity, but I want to be able to say that for this particular, class of storage, that there's enough capacity.
Okay.
Does that make
So
sense?
that way, it's a way to check that the request that you're about to make will succeed.
Yes.
Okay.
So you don't provision a volume and then find out that it won't work.
Okay. All right. Okay, good. Thank you. And then my last question was get node ID.
Yes.
And get node ID is done by the node,
Yep.
the node plugin, and it returns a node ID.
Correct.
So, quick question. I'm just a little bit confused about this part. Who is exactly the node plugin, and where does it get the node? How does it generate the node ID, or where does it get it from?
So do you understand the three services: identity, controller, and node?
Yes. Okay. Yes.
So in this
Node,
case,
that's the attachment.
basically the get node ID is part of the node service,
Okay.
meaning that it is guaranteed by the CO to be executed on the node itself.
That's right.
So when we call get node ID, it's saying get the node ID for me, for this particular node that I am currently running on.
Okay, and that means that the CSI driver generates that?
The CSI driver would generate it, right? So it would say, okay, I was executed on this machine, and I know that the ID for this machine is whatever it is.
Okay.
And it's a way for the CSI driver to be able to say, I don't understand these crazy Kubernetes cluster node names. This is what I understand as a node ID. Please refer to this in all future requests to me. When you refer to a node ID, this is what I mean. And I believe the way that the spec documented it, it said that it was optional, but I'm changing that to required.
Yeah, it says it's must.
Okay, good. So it looks like that change has already been made.
Yeah, and would that mean that in Kubernetes, in our implementation of Kubernetes, there should be a mapping of like, if I say like get nodes -o wide, something like that, or show labels, would I see the CSI
that's
label?
the plan. So right now, what I was talking with Jan earlier was we're gonna put it on as a label on the node object. So if you fetch for node IDs, then you should be able to get it off the node. But like Jan pointed out, the issue there is actually having this container that is going to be calling get node ID, then have permissions to write the node ID object or the node object in the Kubernetes API. That might raise some eyebrows.
So this is where you can do plus or minus things. So if you don't get to control the node ID, I mean the node label, because you are external, right? Then you can say, then we can use CRDs because we are external. And you say, no, you can't use CRDs because you're Kubernetes. And you say, well, if we are Kubernetes, then we can write the node label. You see what I mean? You got to choose one.
Yeah, I mean, technically both of these components are external.
Yeah.
And, we can say that this is what is going to be required to be able to run these components.
Yeah, I mean, you got to pick one.
To take on this, you have to grant this permission. If we decide that for alpha or for beta that we actually need to get rid of this permission, that it's non-workable, then we'll have to consider crazier ideas, maybe have the ID populated onto the attach volume object, but that would require coordination between the node agent and the external attacher, because the external attacher will have to wait until this ID is populated, and then the node agent sidecar container that we have will actually do the lookup and apply it to the attach volume. It actually slows everything down. It introduces more race conditions. So I'd like to avoid that if at all possible, but let's see. let's go with what we have planned right now, and if we get pushback, we can modify it for beta.
Last question is Wednesday's meeting. Is the CNCF storage meeting? Who's leading that? Because Ian won't be there.
I am not going to be there. It's probably G who's going to be running it.
Okay.
Hey, Louis, the code that you showed earlier.
Yeah.
Is that in a repository somewhere? Or?
Yeah, it's in my fork. Let me I'll put that on the minutes.
Okay.
If you don't mind, I'll just create a repo and just stuff it in there, and if any changes happen, we can.
Okay.
But I'll put my fork up here.
Okay. And Saad,
Yes.
if I remember correctly, there's still a controller component that needs to be written as well.
Controller component, as in tree controller component.
Yeah. For what we're doing, no.
It's going to be the volume plugin that you're going to be implementing. There's going to be no changes to the controller itself.
Okay, all right.
The controller is just going to call out to the attach for the attach method that you're going to write for the new volume plugin.
Okay, and that volume plugin will implement pretty much everything, or is it?
It's going to implement the attacher and the base mounter setup and teardown. Not going to implement the provisioner. Notably absent because the provisioner is external.
External, okay.
The attacher technically eventually is going to be external as well, but in this case, since this is the first volume plugin to do this, we still need to implement the attacher, and the attacher is going to create the new API object.
Okay.
Volume attachment object. So all of that is detailed in the design doc. Read through it and make sure it makes sense. If it doesn't, poke me and I'll make sure to update it, and that should be it.
Okay.
All right, guys. Anything else?
I think that's it.
Cool. All right. Thanks, and I'll see you tomorrow.
All right. See you guys tomorrow.
Take care.